Okay, so we've spent a couple of days now on solving equations with variables on both sides of the equation. So now we're going to put together everything that we studied in the material before the last test plus solving equations. So we're going to look at multi-step equations. I've given y'all some notes to take home with you, and we're going to look through a couple of examples and then do a couple of extra ones. So I want you to look at example 1 on your notes. For example number 1, we have 2 times in parentheses 6m minus 1, and that equals 8m. Now, main rule in solving an equation that has things on both sides is that we're always going to treat each side like its own variable expression. In other words, we're going to simplify each side before solving. Solving an equation should be the absolute last thing that you do. So I'm going to look at my right side. On my right side, all I have is 8m. I can't do anything with that. There are no like terms, there's no distributive property, so I'm going to leave the right side alone. But on the left-hand side, I have parentheses. I can't do 6m minus 1, but I can do distributive property. So my very first step before I do anything else is going to be to simplify the right-hand side by doing the distributive property. So I'm going to have 2 times 6m, which gives me 12m. And then I'm going to have 2 times negative 1, which gives me negative or minus 2. And now on the right-hand side, we're leaving alone, so it will still equal 8m. Now, before we move on, make sure each side is fully simplified. If we look, on the left-hand side, I have 12m, which is a variable term, and negative 2, which is a constant term. No like terms, nothing can be combined. Left hand is fine. Right-hand side, all we have is one variable term, 8m. So at this point, now we can start solving our equation. From here, I can either move my 12m to the right-hand side, or I can move my 8m to the left-hand side. I'm a little OCD. I'll always like having my variables on my left, so my preference would be to get rid of the 8m on the right-hand side. And since it's a positive 8m, that means to get rid of it, I'm going to subtract 8m. It does not matter what m is. If m is 2, then 8m is 16. If I subtract 16 from 16, I get 0. If m is 7, then I'd have 8 times 7, and if I subtract 8 times 7 from that, I'll still get 0. So it doesn't matter. And on the right-hand side, I'm also going to subtract 8m. On the left, those cancel out, and since there's nothing else, on the right, the 8m minus 8m equals 0. And on the left-hand side, I have 12m minus 8m. Those are my like terms. And 12m minus 8m gives me 4m. I still have the minus 2. So minus 2. And now I'm left with a two-step equation. From here to solve, I'm going to add 2 to both sides. That cancels, so I get 4m equals 0 plus 2 is 2. And then I'm going to do division by 4. So I get m equals, and 2 divided by 4, please do not tell me that that is 2. Remember, not all answers in math have to be whole numbers. 2 divided by 4 is not a whole number. 4 only goes into 2 half of a time. So you can leave it as a fraction, 2/4, but that reduces to 1/2. Or you could put it in decimal form, which would be 0.5 or 5/10. So those would be your two options for this answer. I really prefer the fraction answer, but both of them are correct. Now, let's look at example 2, part A. For example 2, we have this equation. 2 times x minus 1 And on the other side, that equals 4 plus 2x. Now once again, the first thing we need to do is make sure that each side is simplified. If you look at the right-hand side, I have 4, which is a constant term, and I have positive 2x, which is a variable term. Those are not like terms, they can't be combined. My right-hand side is going to stay just the way it is right now. On the left-hand side, though, once again, I have parentheses, which means the first thing I can do is distributive property. So that would give me 2x minus 2 times 1, and that's going to equal 4 plus 2x. Now from here, I'm going to subtract 2x from both sides to get rid of this 2x on the right-hand side that I don't want. This will go away, so on the right-hand side I'll be left with simply 4. And on the right-hand side, well, I've got 2x minus 2x over here as well, so that also goes away, which leaves me with not 2 but negative 2. Now, this is an unusual situation, in which case we end up with this expression. Our variable goes away completely, and I'm left with the statement negative 2 equals 4. This is a special example because when does negative 2 equal 4? Well, never. No matter what value you pick for x, this is telling you that there is no value for x that will make this statement true. So this is what we call the null set, or a solution set is this symbol right here. Okay, and all that means is that there is no solution. Now, most of the time there will be a solution, so please don't start just every time you get confused saying there's not a solution. The majority of your questions that you work will have a solution. This is a very rare thing to have. The reason why that happens is because if we look at the original problem, let's look at it for a second. We had 2 times x minus 1, and on the right hand side we had 4 plus 2x, and then after our distributive we had 2x minus 2, and on the right, now this is 4 plus 2x, but if I rearrange it and put my variable term first, then I have 2x plus 4. Just looking at this, you can see why these two things, why this statement has no value of x that makes it true. Because no matter what x is, if I multiply that value by 2, and over here I do the same thing, then this number, whatever x is, if x is 4, then this would be 8. Well, if x is 4, then this would also be 8. If x is 3, then this over here would be 6, but this would also be 6. So no matter what x is, this part that I've circled on the left-hand side and this part that I've circled on the right-hand side are going to have the same value. Well, if you take the exact same number and in one situation subtract 2 from it, and in another situation add 4 to it, obviously you're going to end up with two completely different numbers. There's absolutely no way that I can find a value of x that will make this statement true. Now, the reverse of that is our example 2, part B. For this one, we have negative 2 times x minus 1 in parentheses equals 2 minus 2x. Once I use my distributive property, on the left-hand side, I get negative 2x plus 2, because we have a negative 2 times a negative 1, so positive or plus 2, and then that equals 2 minus 2x. Now if I go on to solve this, I want to get rid of this minus 2x on the right hand side, so I'm going to add 2x. which means I also have to add 2x to the right-hand side. This, of course, will cancel, leaving me with 2. And on the left, well, this is negative 2x and positive 2x, which equals 0, so this will also cancel. Oops. And if that cancels, then that leaves me with positive 2 over here as well. So now I get the statement 2 equals 2. Well, when does 2 equal 2? Always. So this is another rare example. In this case, the solution set is all real numbers. The reason that we have that happen is because, again, if we look at the problem, our original problem was negative 2 times x minus 1 equals 2 minus 2x. After distributive property, we got negative 2x plus 2. And over here, again, if I rearrange, I want to put this term first, so negative 2x, and this is a positive, so plus 2. And look at the two sides of the equation. Negative 2x plus 2 equals negative 2x plus 2. Well, obviously, negative 2x plus 2 equals negative 2x plus 2. They are the same thing. No matter what value of x you put in, if you multiply it by negative 2 and then add 2, you're going to get the exact same thing as if you take that number and multiply it by negative 2 and add 2. So this is why this one has an example of all real numbers. Again, these two things are our rare examples. Do not just start saying everything has all real numbers as a solution, because it simply isn't true. Now, we're going to try and look at a couple of examples from the exercises at the bottom, and I want you to complete the rest of them as your homework for tonight, and then we're going to check them in class tomorrow and then go ahead and start doing some activities, some practice with this during class time tomorrow. Alright, so we're going to look at a couple other problems. In the exercises at the bottom of your note sheet, there are 10 questions. We're going to look at questions numbers 6 and 9 together. I tried to pick a couple that were a little bit more challenging, and then like I said, I would like for you to do the rest of them as your kind of your check to see if you're getting it. So question number 6 is 7y minus 1 equals 2 times y plus 3 minus 2. Now, remember, always make sure you simplify each side before you start solving. So on the left-hand side, I have 7y and negative 1. Those are not like terms, so my left-hand side is already simplified. But on the right-hand side, I have parentheses, so that means that first thing I need to do is distributive property. I'm distributing a positive 2, so I will get still 7y minus 1 on the left, but on the right I have 2 times 1y, which is 2y, and then 2 times positive 3, which is positive, so plus 6, and then I still have that minus 2. Now I'm still not ready to solve because my right-hand side still isn't simplified because positive 6 and negative 2 are like terms. So to combine those, I still have the same thing on the left side, but over on the right I have 2y plus 4. Now, the next thing I need to do is get rid of my variable on one side, so I'm going to get rid of the variable on my right-hand side. Since it's 2y, I need to subtract 2y because it's positive. So I'm going to subtract 2y from the left-hand side as well. On the right it cancels, which leaves me with just 4. And on the left, 7y minus 2y gives me 5y. And then I still have the minus 1. So I get 5y minus 1 equals 4. Now I'm just to a two-step equation. I'm going to add 1 and add 1. So I get 5y equals 5. And then divide by 5 on each side. And my solution is y equals 1. Now, another thing that's really important as we are getting to these more complicated problems is to check your solution. We've talked about doing this with some of the simpler problems, but as they are getting more and more complex, it becomes more and more important. So my solution, I believe, is y equals 1. So what we're going to do is we're going to take the original problem. The original problem was 7y minus 1 equals 2 times y plus 3 minus 2. And everywhere where I have y, I'm going to replace it with 1 because that's what I believe y is. So this becomes 7 times 1 minus 1 equals 2 times 1 plus 3 minus 2. Now from here, don't start doing inverse operations. At this point, it's just order of operations. So on the right-hand side, on the left-hand side, I need to do multiplication before subtraction. 7 times 1 is 7, and 7 minus 1 is 6. So on the left-hand side, that problem works out to be 6. Now on the right, I need to do parentheses first. So I get 2, that's multiplication, so 2 times 4 minus 2, multiplication before subtraction, so that gives me 8 minus 2, and 8 minus 2 is 6. So my two sides are in fact equal. So that check tells me that the solution, y equals 1, is correct, because if I replace y with 1, I get an equation that is true. Both sides are equal to each other. All right, last example that we're going to do together, and the remainder will be your homework practice. So number 9, we have 1 plus 2 times b plus 6 equals 5 times b minus 1. Now this one I picked because it has simplifying that's necessary on both sides. Most of them that are on this homework section, either the left hand needs to be simplified or the right, but this one has parentheses on both sides, which means I'm going to need to do distributive property on both sides. Now on the left hand side, I'm going to distribute the positive 2, so I get 2 times 1b is positive 2b. 2 times positive 6 is positive, so plus 12. And on the right-hand side, we have 5 times 1b, which is 5b. And 5 times negative 1, which is negative or minus 5. From there, I'm still not ready to solve. The right-hand side is simplified. I have a variable term, 5b, and a constant term, negative 5. Not like terms, can't be combined. But on the right-hand side, I have a positive 1 and a positive 12. Both are constant terms, so they are alike and can be combined. If I combine them, I'll have 2b, and 1 and 12 make positive plus 13 equals 5b minus 5. Now I have 2 terms on the left, 2 terms on the right. They're unlike terms, can't be combined. So now I can solve. I want to get rid of the variable on the right-hand side of the equation. So since it's a positive 5b, I'm going to subtract 5b from both sides. On this side it cancels. On this side I'm left with negative 3b plus 13. And on the right-hand side I'm left with not 5 but negative 5. Next step, subtract 13 for both sides. So I get negative 3b. And negative 5 minus 13 gives us negative 18. Divide by negative 3 on both sides. And we get b equals positive 6. Now, once again, this is our solution. We believe that b equals 6, but if we want to make sure, and it's always a good idea in a multi-set problem to make sure that you're right, we're going to plug that answer in. So b should equal 6. So the original problem, once again, was 1 plus 2 times b plus 6 equals 5 times b minus 1. Like I said, we got as our solution b equals 6. So coming back to this problem, we're going to simply replace b with 6. So to do my check, I have 1 plus 2 times 6 plus 6 equals 5 times 6 minus 1. Order of operations says I do parentheses first. So on this side I get 1 plus 2 times 12. And on this side, the right-hand side, I get 5 times 5. On this side, I'm going to do multiplication before addition. So 2 times 12 is 24, but I still have to add 1 to that. And 1 plus 24 is 25. And on the right, I have 5 times 5, which is 25. The two sides are, in fact, equal. So my check tells me that the solution b does, in fact, equal 6. That's the one value of b that makes 1 plus 2 times b plus 6 equal 5 times b minus 1. So hopefully that is a pretty thorough explanation. If you need to, you can always rewind the video, go back through examples. Remember, there are rare examples where the solution set is the null set or empty set, and there are rare examples where every single number can be a solution, but those are rare. Make sure and show all of your work the way that I've shown the work on this video, and then in class we'll have more time to practice with additional problems. Please do the remainder of the problems in the section below, and then that way I'll have an idea of who's got it and who doesn't when we get to class tomorrow.